According to the National Electrical Code, NEC Article 250.4. A5, all grounding and bonding systems shall be interconnected to the grounding electrode system. This includes all electrical systems, including public address, personal alert, fire alarm, and cable television systems. There are a few exceptions to the rule requiring all grounding systems to be interconnected. These exceptions are listed in NEC Article 250.4. A6 and include isolated power systems, cathodic protection systems, lightning protection systems, and utility communication systems. While the NEC generally requires all grounding systems to be interconnected, it does not specifically prohibit the installation of individual earthing rods for certain systems. However, the following considerations should be taken into account. Firstly, individual earthing rods may create interference between different systems. The proximity of earthing rods to each other and to other electrical equipment should be carefully considered to minimize this risk. Secondly, earthing rods that are not interconnected may be more susceptible to corrosion due to the lack of a common potential. Thirdly, interconnected grounding systems provide a more reliable path for fault currents to flow, which enhances safety. It is generally recommended to follow the NEC requirement and interconnect all grounding systems to the main ground ring. However, if there are specific reasons for installing individual earthing rods, such as isolation or interference mitigation, the following steps should be taken. Firstly, consult with a qualified electrical engineer to assess the risks and benefits of individual earthing rods. Secondly, ensure that the individual earthing rods are properly sized and installed to meet the NEC requirements for the specific system. And thirdly, monitor the grounding systems regularly to detect any potential issues, such as corrosion or interference. The NEC provides comprehensive guidelines for grounding and bonding to ensure electrical safety. Proper grounding is essential for protecting people and equipment from electrical shock and fire hazards. The main purpose of grounding is to provide a lower impedance path for fault currents to return to the source, which allows overcurrent protection devices to quickly trip and de-energize the circuit. There are several types of grounding systems, including grounded, ungrounded, and impedance-grounded systems. Grounded systems are the most common type, where one of the conductors of the electrical system is intentionally connected to earth. This connection provides a reference point for voltage and helps to stabilize the system voltage. Ungrounded systems do not have any intentional connection to earth. These systems are often used in critical applications where a single ground fault cannot be tolerated, as the system can continue to operate with a single ground fault. However, ungrounded systems are more susceptible to transient overvoltages, which can damage equipment. Impedance-grounded systems use a resistor or reactor to limit the ground fault current. These systems provide a compromise between grounded and ungrounded systems, as they limit the ground fault current while still providing a ground reference. The grounding electrode system is the means by which the electrical system is connected to earth. The grounding electrode system typically consists of one or more grounding electrodes, such as ground rods, ground plates, or metal water pipes. The grounding electrodes must be sized and installed in accordance with the NEC to provide a low impedance path to earth. Bonding is the process of connecting all non-current carrying metal parts of an electrical system together. This includes metal enclosures, conduits, and equipment frames. Bonding ensures that all metal parts are at the same potential, which reduces the risk of electrical shock. The NEC requires that all metal parts be bonded together using bonding jumpers or other approved methods. The size of the bonding jumpers must be sized in accordance with the NEC based on the size of the circuit conductors. Ground fault circuit interrupters, or GFCIs, are devices that are designed to protect people from electrical shock. GFCIs monitor the current flowing in the circuit and will trip if there is a ground fault. Ground faults occur when current flows through an unintended path to ground, such as through a person's body. GFCIs are required in many locations, such as bathrooms, kitchens, and outdoor areas. Arc fault circuit interrupters, or FSIs, are devices that are designed to protect against electrical fires. FSIs monitor the current flowing in the circuit and will trip if there is an arc fault. Arc faults occur when there is an unintentional arc in the circuit, which can generate heat and ignite nearby materials. SIs are required in many locations, such as bedrooms and living rooms. Surge protective devices, or SPDs, are devices that are designed to protect electrical equipment from voltage surges. Voltage surges can be caused by lightning strikes, utility switching, or other events. SPD divert the surge current to ground, which protects the equipment from damage. SPD are recommended for sensitive electronic equipment such as computers, televisions, and appliances. Regular inspections and maintenance of grounding and bonding systems are essential to ensure their continued effectiveness. Inspections should include checking for loose connections, corrosion, and damage to grounding electrodes and bonding jumpers. Any issue should be addressed promptly to maintain the integrity of the grounding system. In addition to the NEC, there are other standards and regulations that may apply to grounding and bonding systems. These include standards from organizations such as the Institute of Electrical and Electronics Engineers, or IEE, and the National Fire Protection Association, or NFPA. It is important to be familiar with all applicable standards and regulations to ensure compliance. Proper grounding and bonding are critical for electrical safety. By following the NEC and other applicable standards and regulations, you can help to protect people and equipment from electrical hazards. In summary, understanding and adhering to the NEC guidelines on grounding and bonding is paramount for ensuring electrical safety. The code emphasizes the interconnection of all grounding systems to a common grounding electrode system, promoting a unified and reliable path for fault currents. While individual earthing rods might seem like a viable option for specific systems, the potential for interference, corrosion, and reduced safety necessitates careful consideration and consultation with qualified electrical engineers. Regular monitoring and maintenance of grounding systems are crucial for detecting and addressing any issues that may arise, thereby maintaining the integrity and effectiveness of the electrical system.